Welcome to your first Polygon project. So let's take a look and see what it's asking us to do here. So imagine that you are working on a large NFT project. Your team decided to move your project to Polygon to increase demand and save on gas. Smart company. Now it's your job to make this happen. For this project, you will deploy an NFT collection on the Ethereum blockchain. You will then map the collection to Polygon and transfer assets over via the Polygon bridge. To put a twist on the project, you will use an image generation tool like DALL-E 2 or Midjourney to create the images for your NFTs. And it's recommending a couple tools for us here. It says we can use Hardhat or Foundry. Me personally, I would stick with Hardhat. I believe that'll be a lot easier for most people. And we have our lovely project rubric here. So the first requirement is to use that image generation software to create 5 images. Now, if you don't want to use DALL-E or Midjourney, that's totally fine. You can use the image generation tool of your choice. All that matters is that you get those 5 images for your NFTs. Second requirement, store items in IPFS using Pinata Cloud. Again, if you feel more comfortable using another service, that's totally fine. Then once you have that, you'll deploy an ERC721 or ERC1155 to the Goerli Ethernet testnet. You should also have a prompt description function on the contract that returns the prompt you use to generate your images. Now, when you're choosing the contract that you want to use, I would recommend the ERC721A. With that one, it allows you to mint batch, which means instead of having to mint one by one, you could basically mint all the NFTs in just one transaction. Number 4, map your NFT collection using the Polygon Network Token Mapper. Note, this isn't necessary, but helpful for visualization. Me personally, I would skip this step. If you've done the previous lesson, you've already used this tool. But if you find it easier to work with, you can definitely use it if you like. 5, write a Hardhat script to batch mint all NFTs. Again, we want to use that ERC721A for this. And then finally, write a Hardhat script to batch transfer all NFTs from Ethereum to Polygon Mumbai using the fxPortal bridge. Now, this is the part that usually gets 99% of most students. And luckily for you, that's exactly what we're going to be covering today in this video. So what we're going to be doing is exactly what you see here. We're going to be approving assets to be transferred, depositing those assets, as well as checking the balance of those assets once we transfer them to Polygon. Now, of course, I can't make this too easy, right? I can't just do NFTs or else you have the solution to this, right? So instead, we're actually going to be working with an ERC20 contract. So we'll be transferring tokens instead of NFTs. That said, though, the process is very similar. So if you understand how it works with the ERC20s, doing it with the NFT should be a breeze. So let's get into the code. So here is the starter project that I have created, which you can find linked in the YouTube video as well as on this project page somewhere down below. Now here is our ERC20 contract. It's a very basic token contract. So here we have our constructor, which is taking the name of MetaToken and then an abbreviation of MTA. We have a min function, which is only going to be accessible to our owner. And then lastly, we have this decimal function here. Now, if you haven't seen this before, what this does is that it changes the amount of decimals that the token uses. Normally, this would be 18 decimals, but to make it a little easier to work with, I'm setting the decimals to 0. This way we don't have to worry about fractions of a coin. It's just going to be a lot easier to work with. So now that we've seen our token, we'll go ahead and take a look at the scripts that will run. So the first script we would run, of course, is deploy.js. This is going to take that token contract and put it onto the test network for us. What you see here is a basic Hardhat script. We have the standard HRE require here, just pulling in those Hardhat functions that we're going to be using. We have a token variable here, which is going to be holding the result of the contract deployment. So here you can see that we're deploying our meta token. And then once it's deployed, we're just taking the address and printing that out to the console so we'll be able to use it for our other scripts. So now once we have it deployed, the next thing to do, of course, is to mint. So here at the top, we have some more require statements. The first one, of course, is the mandatory Hardhat one. Here we're taking the JSON file for the token contract that we're deploying. And then what we're doing with this is doing a dot operator to get that ABI that we need. Because when you want to get the instance of this contract so you can call it, there's two things that you need. One is the contract address and the other is the ABI. The ABI is created when you compile your contract. Chances are you've seen this before, but if not, you go to your artifacts and then contracts, meta token, and then you can see that JSON file here. And then the all-important ABI is right there, which you can see is part of this greater file, which is why when we declare this variable, we do this .abi. So instead of getting that whole file, we're only getting that ABI information that we need. Now here is the token address variable. Now I already deployed this contract earlier, and when I did that, this is the address that I received. And then this is just the public wallet address that I'm using for the tokens to be deposited into, and this will also be the wallet address that I use on Polygon as well. Now going into the function, you see that we're doing a call with getContractAdd. So this is getting the instance of the token contract that we deployed onto the testnet. And you can see we're passing in that ABI and that token address. Once we have that, what we're going to do next is the mint function. So here we're passing in our wallet address, and then we're just saying that we want to mint 1,000 tokens. Here we're waiting for that transaction to finish, basically for everything to be confirmed on the blockchain. Then once it is, we are console logging out that you now have 1,000 tokens, hopefully. Just letting us know that everything completed successfully and how many tokens we have. And then after we mint is the one that everyone really wants to know about, which is the approve and deposit functions. So let's take a look at this. So at the top, again, we have our require statements, but some of these are a little new. We got our Hardhat, of course. We have the ABI file for the fxRoot contract. Now the fxRoot contract is what makes all the magic happen. This is the one that has that all-important deposit function. And what that does is it takes the tokens that we want to transfer to Polygon, and then it transfers them. So really important, right? And then this is the ABI file, again, for our token. And then here we have the token address, again, for that token contract that we deployed. And as before, we're just getting that ABI for our token contract again. Here is the location of the fxRoot contract. Now, if you're wondering where this comes from, I'll be showing that to you in just a moment. Here we have, again, our wallet address, which is just the public address of our wallet. And now here is the actual magic. So the first thing that we need to do is get both of the contracts. So here we're getting our token contract. And then the next thing we're doing is getting the fxRoot contract. And then once we have both of those things with our token contract, what we want to do is make it so that the fxRoot contract is approved to take a set amount of tokens. So in this case, we're saying that we want the fxRoot contract to spend up to 500 tokens. And so when we do this approve, it allows it to do just that. And then once we have that approval, we go ahead and console out log that we have got the approval. And then next is the deposit. So now here we're using that fxRoot contract. We're calling its deposit function, and it's taking a few different things here. So the first thing it's taking is the contract of the token that we want to transfer. Since it's an ERC20 contract, we're passing in the ERC20 contract that we deployed, which is this one here. Next is the wallet address where the tokens will be transferred to on Polygon, which again is going to be our wallet address, same one. Here is asking how many tokens we want to transfer to Polygon. So we're going to put that 500 that we authorized before. And then this here is the data field. Now I'm going to be honest with you, I have no idea what this is actually used for. The documentation for this is pretty light, but I do know that you have to have something here, which is why I just have this arbitrary value here. You can change this if you want. Personally, I would just keep it. If anyone out there actually knows what this is for, please let me know. Then after we do that, we're waiting for that to confirm. And then we console out log that our tokens are deposited. Now after about 20 or 30 minutes, this will show up on the Polygon account. The reason why it takes 20 to 30 minutes is that it's also mapping these tokens and creating a contract on the Polygon network to facilitate the transfer as well. Now, once you have the tokens transferred, what you'll be able to do is get the contract address for your token on Polygon, which is what I pasted in here. And then once you have that, you can call your GetBalance function using that new contract address, but the same ABI. You don't have to change that because it's still the same functionality. And then with that, it'll tell you you have 500 tokens on Polygon and that you're awesome and you have completed your project. So now to go a little deeper into where some of these things come from. So going back to approve and deposit, we have this fxRoot address, but where does this thing come from? So if we go to the documents for fxPortal, you can see there's all different kinds of contracts that they provide. So for instance, when you're doing your project, you can scroll down and you can see a list of all the ones that are available. So for an ERC 721, this is the one that you'd use for that. But since we're doing an ERC 20, we're using this one here. And you can see this contract address is the exact same one that we're using in our code. So that is where that comes from. And then if you're wondering how we know the process to approve and deposit in order to get these transfers going, the instructions for that are here as well. So here you can just go to ERC20 transfer and you would just click Ethereum to Polygon. And you can see some of the notes here, right? So it says you have to deploy your token to your testnet. Once you do that, you have to call the approve function of your token. And then you can call deposit, which will create that transfer. Alternatively, you could do map token and then deposit, but there really isn't a need to do that since deposit does it all for you. But if that's something you want to do, you can certainly do it. And then as noted here, after you have performed that deposit function, it will take 22 to 30 minutes for everything to sync up. Now, as far as the ABI for your fxRoot contract, since you're not compiling this yourself, what you have to do is you can go to Etherscan and then just paste that contract address here. And then what that's going to do is bring up the contract, of course. So here you can actually see that deposit that I did earlier when I was testing this. But if you go to contract, here you can see the code for it and the different functions that are available. So here's that deposit function, for instance, that we're going to be calling. But what we're here for is the ABI, which if you scroll all the way to the bottom, well, almost to the bottom, you will see this right here, contract ABI. Now there is an option to export this in JSON, but it does add some additional random things to this when you do that. So what I recommend is just clicking this copy ABI to clipboard. And then when you go to your code, you can see here I just created the JSON file in the root directory. And then you just paste it in, which is exactly what I did here. And that's how you get your ABI. Now, when you do this for your NFT project, it's going to be the same thing. So you'll pull up the NFT contract on Etherscan. You'll scroll down, you get your ABI, you'll paste it into a file, and then pull that into your script. So last but not least, we'll just take a look at our Hardhat config here real quick. Not much to see here. The only thing that I have added is the Goerli network and the Mumbai network. Now, unfortunately, you can only do this on the Goerli network, which means if you do need test tokens, please reach out on Discord to get those, and we'll be more than happy to assist you with that. Presently, they do not have any of these contracts deployed on Sepolia. Now, I have requested that they do this. I don't know if they will, or if they do, when that would happen. But in the meantime, this is required, unfortunately, just so you know. So now to show that this does work, now here is the wallet I was using for the previous transfer. So in the history, you can see that we had a contract created. This is when I deployed the contract. Then here we minted 1,000 tokens to our wallet. We approved the root contract to take up to 500 tokens. And then here you can see that this is the address for that root contract. And then finally, we called that deposit function. And here you can see that it took 500 tokens as we decided in our script. And you can see all that function data that we passed in. So we got our token address here, we've got our wallet, the tokens, and that random data that we put in. And again, if you go to the root contract itself, you can also see that deposit function showing up in the transactions here as well. And then after about a half hour, it did show up in my Polygon address. And here you can see the 500 tokens, 500 meta tokens. Now this is important. This is basically what's going to get you to that final step of doing the GetBalance call. So if you click on this transaction, and then you click on this meta token here. Or actually, yeah, you can just click on it right there as well. This is the contract address that it creates for your token on Polygon. You can see that it's different from the one on Ethereum. So what you would do is copy this and then go back to your code, to your getBalance function. And you can see this is the one that I pasted here, right? Exactly the same. And that is how you're able to call balance of on that contract on the Mumbai test network. So real quick, I'll now run all these scripts just so you can see them in action. So the first one that we'll do, and then in this way, you'll be able to see the process firsthand as well to really help it to sink in. And because I'm a little lazy, we're just going to scroll up until we get to the pre-typed commands. So the first one that we're going to do here is the deploy, which should just take a moment. And here you can see we have deployed it to this address. So then what you would do is copy this address, go to your Mint, paste in that address here where it says token address, save it, of course, and then approve and deposit. We know we're going to need it there as well, so we'll go ahead and paste that there too. And that should do it. So now the next one that we're going to call is our mint function, which again is going to mint that 1,000 tokens to our wallet. So we'll go ahead and call that. Okay, we have now minted 1,000 tokens. And if we go back to our account on Ethereum and we refresh this, here we can see the contract deployment here and then that mint that we just did. So now we've minted, and the next step is the one we all want to see, the approve and deposit. So we'll run that now. So what it's doing right now is getting that approve for the fxRoot contract, which it has now received. Now we are calling the deposit function of that root contract, which has completed successfully. And now, if we go back here, we can see the approve and the deposit. And if we go to the fxRoot contract itself, we can see that deposit right here as well. So in 20 to 30 minutes, this will show up here, which at that point you'd be able to get the contract address, call your GetBalance, and be all set. So for your NFT project, this should help quite a bit. A lot of it's the same, except you're going to be using that other fxRoot contract for the ERC 721. One last thing, I believe. Now, one last thing is this environmental variable here. Now, for the private key of your wallet, what you'll want to do is paste that here, because that's what's going to be used for all of your transactions. And as a refresher, if you don't know how to do that, all you got to do is just go to your MetaMask, click here towards the top, then the three dots here next to the account you want to use. Go to Account Details, Show Private Key, and then you just type in your password, hit Enter. It'll show that private key for your account, at which point you would paste it into this file. And then lastly, all you'd want to do is rename this file and then just remove that example part. Otherwise, it won't have access to that variable, and you'll be scratching your head trying to figure out why nothing's working. So that's it. So I hope this helps you with your project for this module. I know you can do it, and I will see you on the other side.